Hello, everybody. Greetings again, and welcome back. So we're going to get into lesson 5. So thank you for tuning in again. Well, I hope everybody is doing well. So we're still doing vectors and scalars. Hmm? So in today's lesson, lesson 5, we're going to look at properties of vectors. Properties of vectors. Vectors. So okay, let us start with equality of vectors. So, or you can just say equal vectors here. So I can say equality of vectors, or we can just say equal vectors. So how do we define the vectors that are equal? Okay. So we say that two vectors are equal. Two vectors are equal if they have the same magnitude and the same direction. And the same direction. So we say they are equal if both of those things are the same. Okay. So it has to be the same magnitude and the same direction. So this is how we define the quality of vector, the equality of vectors. So we say they are equal if they have the same magnitude and also they have the same direction. So the two things have to be the same. And then the second thing we're going to look at here is what? Negative vector. What is a negative vector? We also have a negative vector. Okay. So how do we define a negative vector? We say a negative vector is a vector that has that has the opposite direction to the reference so it has the opposite direction to the reference direction to the reference positive direction. So this is another important definition here that we need to know. Okay. Sorry about what finding there. So a negative vector and the equality of vectors. These two definitions are very important. You will see when we're doing examples that that's just how these two are important. Okay. Now let's get to addition and subtraction of vectors. Okay. How do we add and how do we subtract vectors? So addition and subtraction of vectors. Subtraction of vectors. So okay. So we will look at addition first. Okay. So okay, we say that when vectors are added, we need to take into account both their magnitudes magnitudes and direction. Magnitudes and directions. So then we say we subtract vectors if they act in opposite directions. So if they act in opposite directions. Relative to each other. Relative to each other. Relative to each other. Okay. And then, so when we do addition and subtraction, we need to understand two definitions very well. The resultant vector and the equilibriant. Okay. So we need to understand what a resultant vector is. The resultant, or you can say net vector. So it's defined as the following. We say that the resultant vector is the single vector the single is the same is the same as the individual vectors acting together. As the individual vectors acting together. Acting together. That is how it so this is what it says. The resultant vector is the single vector whose effect is the same as the individual vectors acting together. Okay. So it's a vector sum. It's a vector sum of all the individual vectors involved in the scenario. Okay. And then the other definition which is important here is what? The equilibriant. And it's not the same as the resultant vector. Okay. Equilibriant. So the equilibriant is the vector which has the same magnitude. Okay. Same magnitude, but opposite direction. To the resultant vector. Resultant vector. So this is how they what? They relate. So we say that they have the same magnitude, yeah, but opposite direction because we use the resultant vector. Okay, so we use the resultant vector to define the equilibrium. Okay, so the resultant vector is involved in the definition for the equilibrium here. So we say that the equilibrium has the same magnitude but opposite direction to the resultant vector. See, so it is measured relative to the resultant vector. So it is measured in comparison to the resultant vector. Okay. So, so there is a step-by-step procedure here. So it says there are 6 steps here, and then we call this method head to tail. So I want to outline the head to tail method. So the head and the tail here is the head and the tail of the vectors that we described before. Okay. So it's head to tail method of vector addition. Of vector addition. Okay. So there is a step by step. Okay. So step number 1. So what do we do? You draw a rough sketch. Draw a rough sketch of the situation. Draw a rough sketch of the situation. And then step 2, we choose a scale. Okay. You choose a scale. Choose a scale and include a reference direction. And include a reference direction. Okay. So we choose a scale. It's just like we did before. Okay. So we do the same thing here with the scale, so that we use a scale such that a drawing can fit onto the page, isn't it? Then after that, step number 3 is you choose any of the vectors. Okay? Choose any of the choose any of the vectors and draw it as an arrow and draw it as an arrow. draw it as an arrow in the correct direction. So the correct direction in this case is the reference direction that we chose, okay? In the correct direction. So unless it's a negative vector, because then if it's a negative vector, then it will be in the opposite direction. So it must be in the correct direction and of the correct length. Of the correct length. So the length will be determined by the scale that we chose, isn't it? So, and then remember to put an arrowhead. Remember to put an arrowhead on the head no, on the end, sorry. Not on the head, on the end. On the end to denote its direction. So the arrow will be at the head. So when they say at the end, they mean at the head. So the head of the vector. So it means meaning on the opposite end of the tail. And then the fourth step here is what? You take the next vector and draw it. So you take the next vector, and draw it. Guys, you should remember these steps, okay? You are not given the steps here on the formula sheet today, so but I think I'll show you when we're doing an example, okay? So you take the next vector and you draw it as an arrow. It's an arrow starting from the head of the previous vector. So now when they say starting from the head of the previous vector, meaning, for example, okay, wait, let me finish the statement there. So starting from the head of the previous vector in the correct direction. In the correct direction. And of the correct length. Again, just like the previous vector. And of the correct if say for example you had a vector like this, you start another head. So when you say it, take the next vector and draw it as an arrow starting from the head of the previous vector. So if you had a previous vector like this, so the next vector can go from, so starting from the head of the previous vector, it will start here on the head and going wherever it goes. You see, they mean. So when you go to the next vector, then you start from the head of the previous vector and you go, see, until you reach the last vector, whatever the last vector happens to be. Okay, like that. So meaning in each case, you start on the head of the previous vector in the correct direction and of the correct length, because it's not always the case that all the vectors will be in the same direction. Sometimes the vectors are in different directions like this, okay? And sometimes they may be in opposite directions also. So this is what they mean here. Just wanted to show you. So now let's go to the next step. Also, number 5. Okay. So step 5, what happens? So you continue until you have drawn. So continue until you have drawn each vector. Continue. So each time starting, so each time starting from the head of the previous vector, starting from the head of the previous vector. Of the previous vector. So now, in this way, the vectors are the vectors are also very. So in this way, the vectors to be added are drawn one after the other. Are drawn one after the other. After the other, head to tail. Head to tail. So that's why this thing is called head to tail method. But okay, guys, don't worry if you don't understand at this point. Okay, I will make it. I think it will become clear as we're doing examples. Okay, so the last step number 6. So this is where we find the resultant. Okay, so the resultant vector. So the resultant vector. The resultant vector in this case is the vector drawn. Is the vector that is drawn. That is drawn from the tail of the first vector from the tail of the first vector to the head of the last vector. So it's from the tail of the first vector to the head of the last vector. So its magnitude can be determined. So its magnitude, we can look at the length, okay? So its magnitude can be determined. Can be determined from the length of its arrow. So from the length of its arrow of its arrow, so again using the scale, okay, the scale that we decided from the beginning, okay, using the scale so its direction to can be determined from the scale diagram. From the scale diagram. Okay. So let's just find down the steps again. Okay. So starting from the top, so you draw a rough sketch of the situation. See? Then you choose a scale and include a reference direction. So from the previous examples there, so a reference example like for example, you can use an arrow like this and say this way is the north. I don't know if you remember from the previous lessons. This is an example of a what? A reference direction here. And then number 3, they say what? You choose any of the vectors and draw it as an arrow in the correct direction and of the correct length. Remember to put an arrowhead on the end to denote its direction. So it's on the end of the vector. Okay. So it's at the head to denote its direction. Take the next vector and draw it as an arrow, starting from the head of the previous vector in the correct direction and of the correct length. So the sketch I was showing you here. And then you continue until you have drawn each vector, each time starting from the head of the previous vector. In this way, the vectors are to be added. The vectors to be added are drawn one after the other, head to tail. And then, so the resultant vector is the vector that is drawn from the tail of the first vector to the head of the last vector. Its magnitude can be determined from the length of its arrow using the scale. Then its direction too can be determined from the scale diagram. So sometimes, guys, you will need a what? A protractor. A protractor is a semicircular protractor, okay? To determine the what? The direction. It will help you with the direction, okay? If, for example, say you find your vector is pointing diagonally like this, if your resultant happens to turn out diagonally like that, okay, you will need an instrument like this so that it can help you to find, for example, the bearing or the compass direction. Okay. So, okay. So let's leave it here for lesson 5. Okay. I hope that was helpful. So in the next lesson, we will do examples, okay? I will come with an example and we follow these steps in order to draw what? A vector, and to draw all the vectors and to find the resultant, okay? So in lesson 6, I hope you tune in. We're going to do examples using the tail to head method. Yeah, and then we're going to go step by step from 1 until 6. So you can see how we do it. Thank you for watching again. Thank you for tuning in. Bye-bye for now. I hope you tune in for lesson 6 and stay focused.